I work at Acumentrics. I was actually a student with Acumentrics project a couple years ago. I was offered a job following that. If you still want to see it, that's online. We're actually sponsoring 2 projects this year. First time we've done it. One is purely electrical, and one is a project that I have been fighting to get sponsored and put into this program for several years now. That project is this one, Fault Line. I'll read the title just because formalities. Power signature analysis for fault detection and predictive maintenance. I'm going to get to what that means when the computer comes back up. And do we have a clicker? No. Click. Excellent. And you want to move the cursor all the way to the right? Thank you. So, Acumentrics, got a laser pointer. Acumentrics is a developer of ruggedized power systems, primarily for the defense and military industries. We sell products to a lot of the people that you may have heard of: Newport News, Raytheon, General Dynamics Electric Boat, GDMS, Textron. Basically, what we do is provide power for your devices regardless of the environment. The company was actually founded by a couple people who used to work at Schneider back when it was APC, and they decided that the power system that sits under your cubicle in an air-conditioned lab isn't realistic. So we went rugged. Click. Still going to do that every time. So an easy way to describe what our products do, the primary ones being uninterruptible power supplies, is to look at a UPS. We have 2 here, the B2K, which is our original model, the 1U, which is a 1U rack mount model. Now up here you see a Pred B. Now what this is, obviously it's a drone, and behind every one there's a ground control station. This ground control station involves a suite of highly advanced communications, controls, and other systems. Now that can be anywhere in the world, but one thing is certain: you don't want the power to go out when you're piloting a drone. So behind every single one of those is one of our units, which makes sure that no matter what's powering that ground control station, it could be a gas generator, it could be a suite of batteries, it could be 50 guys riding bikes. The fact is, it cleans the power, it gets it delivered to the device in the way that they need it. Now, I said it's rugged. How rugged? Click. Well, we like to test that. Here's one of our batteries being shot by a 39mm AK-47 round. Reason being, lithium-ion batteries blow up if you use the wrong kinds. If you're in a combat environment, you're in the cold, you're in the desert, you have to make sure your stuff keeps working. We make sure ours keep working. Click. But that's actually the subject of the project. Our new market: medicine, fun, first response. Point behind this is the same thing. You need power for your devices. You're piloting a drone. You have to make sure you have the batteries charged. You're going overseas to a place that doesn't have safe grid power. There are surges, there are spikes, there are blackouts. How do you make sure that a portable ultrasound machine can still work? By providing clean power. That right there is a portable data center we helped design a power system for, used for facial recognition. No Wi-Fi, no data, just a data center about this big, able to scan about 50 faces at a time. But again, it's not the subject of this project. Click. The closest thing I could actually get to talking about the project is actually talking about a previous project. 2 years ago, they developed a power distribution unit. It's a glorified power strip. Don't worry about it. Click. But what they did was put advanced sensors in, sensors that can sense. That was a nice one. That we can look at the voltage at a high frequency, and we can look at those waveforms and get advanced analytics out of it. This is where it sits right now. It's a smart dashboard. We have the board, very small, very easy. The brains, though, is outside of it. This right here is our meters. That's what it looks like today sitting on a lab. I didn't have time to get a clean picture. But what we did get was data. And in this age, data is everything. Which brings me to the project. We've already talked about digital twins all over, so I'm not going to bore you. Instead, I want to talk about why I chose this based on the industry, the technology, and where we are now. So we have data, the most rudimental. We look at our power triangle. I'm sure everybody's seen this before. Not that important, but it does give us insight. We can do this, and we can get this data just by simple sensors. If anybody's used an Arduino or a Raspberry Pi, you've probably used some form of analog to digital controller. You can probably grab a little bit, see what a voltage is, know that your LED's on, whatever you want to have. Going farther, a lot farther, we have a meter on a house or a current sensor. These give us the pieces that we need to start to create a footprint, an image, an idea of a product. Which brings me to the beginning. This idea started with an idea of a technology called non-intrusive load monitoring, NILM. Sounds terrible to say. I don't say it. This is a patent filed by 2 MIT students, well, graduates, on the very first concept of it. It was just steady state. It didn't care about when things were going up or down. It just cared where it was and then where it was. It was kind of basic, right? Fast forward, there it was, great. I forgot my zooms. Fast forward, and we get a little bit more advanced. 2003, a magazine published by IEEE took this idea and used what we've learned now and actually said, well, let's say I have 3 things connected to the same bus. How do I figure out what's my computer, what's my heater, and what's my microwave? It can be done. We look at higher harmonics, we look at the transient responses, and then we can actually pinpoint what's going on without having to have everyone plugged into a different guy and putting a different sensor on every single one. But this is, again, just doing normal analysis. This is when I got interested in it, and when I first proposed the project. 2016, university out of Romania published a paper about using power signatures. This is a washing machine cycle happening. It's pulling every 1 second. We see a heating cycle. We see wash, rinse, whatnot. Doesn't really mean much until you look at how it happens over time. We've created a model. When we look at that model, we can start to see differences, failures. This isn't putting sensors inside the thing. It's a black box. It's non-intrusive, meaning that it can go on any product. And I proposed it that year, got denied. It wasn't until the next year when a team of MIT graduate students published another paper on the subject, this time in conjunction with the US Coast Guard, that we got some interest. This right here is the NILM dashboard. They hooked up sensors on every single system, basically back to those breaker panels, and started just listening. What's happening on the ship? They just monitored first, but then they said, okay, let's start to figure out what we can do. The data they collected, it's a lot better than 1 time a second. It's actually 8,000 times a second. As I mentioned, when you start getting faster, you can start figuring out what happened. And what they did is detect a fault in a pump. It's supposed to turn off, on, off, not that fast. They detected that it started going da-da-da-da-da-da-da-da-da-da, and they said, oh, shoot. They went to it, diagnosed it, there was a failed part, but it didn't cause a catastrophic failure. They stopped it before that happened. Like the previous presentation, repairs cost a lot of money. But I noticed something. This happened in 2018. These guys didn't really model anything. It's just turning on and off fast. So we had one team that modeled, one team that sensed a lot, but it only went on and off fast. Nobody's combined it. That is the goal of the project. A functional prototype capable of modeling a single connected device and detecting abnormalities in behavior. Must be non-intrusive and rely solely on the power signature. A parent company of ours has another subsidiary that actually that works with motors, but they have to put sensors in the motor. Well, it doesn't work if you can't open the motor or it's out somewhere else or for any other reason. You want to buy something off the shelf and know when it's going to fail. That's key. So, what am I asking? Research, learn. There's a lot to learn here. Machine learning is not something covered in computer engineering, definitely isn't in electrical, and in CS it is barely touched. Design. I don't have an idea for the design yet. That's up to you guys. You have to figure out how best to use these sensors and these chips and actually get this data and perform the analysis with a prototype. Simple. Sounds simple. It's not. But ultimately, you achieve that, you achieve your best anticipated outcome, which is ultimately the goal of this project. So, once again, if you want to get into the details, you can look at my proposal. I put the articles there, and I actually put copies of all the publications there to be read. So let's break down a little bit of our tasks, because frankly, the project's non-trivial. We're going to be asking a lot. For ELEs, it's pretty simple. In fact, it's covered entirely by your curriculum. So congrats. Everybody can apply, I guess. Simple analog and digital circuit design, linear systems and signals. I am sure everybody 1 year before graduation has passed these courses, or at least knows what they're talking about. I add a little addendum here, a little DSP. That's actually the bread and butter of our school, so you've probably dabbled in it. If you worked in any research labs, it can be helpful. But at the end of the day, it's not necessary. There are, however, additional skills. If anybody knows anything about machine learning, it is equal parts math as it is science. So I would really, really strongly recommend that people interested in the projects have their math chops nice and fresh. I don't know what we're going to need yet, but chances are we're going to need it. In addition, because of the team size, at this point I believe it's 2 people, 1 ELE, maybe a double major, and 1 CPE. We may have to expand, but otherwise I need shared responsibility. I need the electrical engineer who likes to program. Scary, I know. There are a couple though. Somebody who's interested, who can actually perform these duties, because you're going to be working together on this. To ask one single computer engineer to do this, that's just crazy. We're not doing that. So I need a shared responsibility, I really do. So anybody who's passionate on the electrical side, get ready to get your feet wet with some computer work. The sensing part of it, hooking up the circuit, it's a decent amount of work, but you'll be done quick. On the CPE side, once again, almost covered by your curriculum. OOP, we've all done C++, great. You've done some C, that's also great. Python, conveniently enough, is the most popular language for doing any sort of machine learning. There's obviously ways to do it in every language, but that's the one that's easiest. We can get it done the fastest, and that's what we want to have done. I do have some requested skills. It's just 1. You should have done this before. Not should have, but it would be nice if you've done this before. Whether it's using TensorFlow and doing their crash course, whether it's taking Stanford's course on it, or just trying to figure out how to detect what a letter is, or whatever you want to do. There's a lot of things. You can do a machine learning algorithm that can learn, and next thing you know, you can apply it and win at Flappy Bird. It's all stuff you can do. I would really like that. Additionally, like last time, it is the exact same requirements all around. I did put in something else though. As I was drumming up ideas, I realized we can go further. Much like you saw in the 2003 magazine image I posted, identifying different devices on the same bus. I would love for us to be able to do that. And that's the thing that's about to fade in, because I messed up the animation. Beautiful. Then, because we've done, back that one up. Then, because we have this smart PDU that can sense all these things with just as much power as we need, it was designed to be overkill. I would love to put that into it. This is our new product. I'd rather you guys design the second version than me, so let's get started. With that being said, I will touch briefly on who I am. I'm a software engineer. At Acumentrics, that title doesn't really mean anything. I'm doing electrical, I'm working on PCBs, I'm debugging systems, I'm working with customers, I'm going to conventions, I'm talking, I'm doing networking, everything. But my bread and butter is software engineering. You'll have me as a technical director. Additionally, Bill, our VP of engineering, he is an electrical powerhouse, no pun intended, as well as any of the staff.